We're going to move on to some graphs of functions and their inverses. Just as a quick reminder as to what's going on, we're just going to do rough sketches here. So for example, f of x equals the natural log of x. We'll do that in green. We should be familiar with this. We know that the natural log function has an x-intercept at 0. It's got a vertical asymptote at x equals 0. I meant x equals 1 is the x-intercept. And it's a monotonically increasing function. Looks something like that. Its inverse, well, if y equals natural log of x is our original function, then x equals natural log of y is the inverse, and if we exponentiate, we get e to the x equals y. So that tells us that f inverse of x is e to the x. Well, that's an exponential function, and we know that that has a horizontal asymptote at y equals 0, a y-intercept at y equals 1, and it is also monotonically increasing. Looks something like this. Whoa. As a reminder, inverses, when graphed, are symmetric to the original function with a reflection over the line y equals x. It's possible that these graphs cross over the line y equals x. I'm not really sure. I also don't really care. But the basic shape is all I'm looking for here. All right, so moving along to the next example, if we have an exponential function, how is that going to compare to the last one? Well, we're dividing x by 2, so that's probably going to mean a horizontal compression, or actually it'll be a horizontal stretch. So when we graph that, it'll look very similar to the exponential function that we just graphed. I'll do that in blue. We have the exact same horizontal asymptote. We'll do that in blue, I said. And we have the exact same y-intercept at 1. But it's going to take twice as long horizontally to grow because when x equals 2, we're raising e to the first power. So we have to go a little bit farther horizontally to get our growth going on. So it's going to be maybe a little bit horizontally stretched. Still the same basic shape. When we look at the inverse, we have y equals e to the x squared, or x over 2, is our original function. So our inverse is going to be x equals e raised to the y over 2. And if we solve for y, we take the natural log of both sides. We get natural log of x equals y over 2, or 2 times the natural log of x equals y. So f inverse of x equals 2 natural log of x. So the horizontal expansion that we did on the original function is going to turn into a vertical expansion on the inverse. So still the same vertical asymptote, still the same x-intercept at 1, but it will be maybe a little bit more stretched, twice as stretched for vertically. Once again, the line y equals x is that line of symmetry, and that's how we can kind of relate the two functions. All right, keeping on. We've got the graph of 2 plus the natural log of x. Well, keeping with our natural logs in green, we would have originally crossed at 1, 0, but with a vertical shift of 2, this is going to be our point that we're going to go through. So our x-intercept is going to be a little bit less rational. Same basic shape though, just shift it up 2. And finding the inverse, if we know that y equals 2 plus the natural log of x, then our inverse is x equals 2 plus the natural log of y. So x minus 2 equals the natural log of y, and if we exponentiate, we get e to the x minus 2 equals y. So in this case, f inverse of x equals e raised to the x minus 2. So our original e to the x function is now shifted 2 to the right. So our original natural log function was shifted 2 up. Our exponential function is shifted 2 to the right. Everything that was x is now y, and everything that was y is now x. that's how inverses work. Once again, we see the line y equals x is the line of symmetry. If we reflect one over the other, if we reflect one over the line y equals x, we get the other. All right, so it's all kind of the same thing over and over again, but we'll keep on going. Why not? We've got this exponential graph. This has two things going on. First of all, it is shifted one to the right. So instead of crossing at 0, 1, it's going to get shifted to the right and go to 1, 1. But wait a second, it's also a vertical stretch by 3. So we know that this point right here is going to be a point on our graph. If I let x equal 1, then y equals 3. So we're going to have still, we didn't shift vertically, so we don't change our horizontal asymptote at y equals 0. It's going to look something like that. And if we look at y equals 3 times e to the x minus 1, and we invert it by switching the x and the y, and we solve for the new y, we get x over 3 equals e to the y minus 1. We get rid of those exponents using logs, and we get natural log of x over 3 equals y minus 1, so y equals the natural log of x over 3 plus 1, or f inverse of x in this case, equals the natural log of x over 3 plus 1. Notice that the horizontal shift of 1 to the right has turned into a vertical shift of 1 up. And the vertical stretch by a factor of 3 is going to turn into a horizontal stretch of factor 3. So everything just gets flipped around, so the point 1, 3 becomes the point 3, 1. Our y equals 0 asymptote becomes our x equals 0 asymptote. And it's going to look something like that. And once again, we can see that the line y equals x is our line of symmetry. One more example, this one starting off with the natural log function. The transformations that we're talking about here, the plus 4 is going to shift us 4 to the left, and the 1/3 out front is going to be a vertical shrink by a factor of 3. So a horizontal shift is going to move our asymptote. That's new. We're going to go to the left, 1, 2, 3, 4. So x equals -4 is our new vertical asymptote. And when x equals -3, that's when we're going to take the natural log of 1, or that's when we're going to cross the x-axis, because that's when we've got a 0. And then it's going to be squished vertically because of the 1/3. Still the same basic shape, just kind of squished a little bit. So our y equals 1/3 natural log of x plus 4 can be inverted to x equals 1/3 natural log of y plus 4. Solving for y, we multiply both sides by 3. And we undo the logs by exponentiating. We get e to the 3x equals y plus 4, or y equals e to the 3x minus 4. F inverse, in this case, equals e to the 3x minus 4. Once again, our transformations correspond. A shift of 4 to the left turns into a shift of 4 down, because horizontal becomes vertical. A vertical compression by a factor of 3 turns into a horizontal compression by a factor of 3. Everything has a corresponding part. So we go down to 1, 2, 3, 4. That is our new horizontal asymptote at y equals 4. We've got, when x equals 0, we've got y equals -3, because 1 minus 4 is -3. And we've got ourselves a graph that looks just like so. And once again, we see that the line y equals x is our line of symmetry. Yay!